Students, we will do question number 9. So let me write the question down. The function f and g are defined for all real values of x such that f of x is 3 times x negative 2 raised to the power of 2 positive k, and g of x is 5x negative 1, and k is a constant. Part A, given that the range of gf is gf of x greater than equal to 39, we are asked to find the value of k. That's the first part. The next part is, for this value of k, find the range of fg, and you have part C, the function h is defined such that gh of x is 35x positive 19. We are asked to find g inverse of x and h of x. Okay, so quite a sum. Now let's move on to do the question. So first let me write the function. F of x is given as 3x negative 2 raised to the power of 2 positive k. G of x is given as 5x negative 1. Now given that the range gf is such that gfx is greater than equal to 39, we are asked to find k. So foremost, what I wish to do is we will have to find g of f of x. This is equal to g of f of x is this entire quantity, so it's going to be 3x negative 2 raised to the power of 2 positive k. Now this has to be substituted into this quantity, so this is going to be 5 times of 3x negative 2 raised to the power of 2 positive k negative 1. Now I distribute 5, so 5 times of 3x negative 2 raised to the power of 2 positive 5 times k negative 1. I don't have to take the square, so let's just have this as g of f of x being equal to 5 times of 3x negative 2 raised to the power of 2 positive 5k negative 1. Given that g f of x is greater than equal to 39, so this means we are looking for the minimum value, and that is occurring when 3x negative 2 whole square is equal to 0, because this is a quadratic, so the smallest value that this would take would be equal to 0. So this in turn would mean we now have 5k negative 1 is greater than equal to 39. So 5k is greater than equal to 39. Negative 1 when it goes to the other side will become positive. So 5k is greater than equal to 40. Therefore k is greater than equal to 40 over 5, which means k is greater than equal to 8. Okay, so that's a value for k. So let's move on to the next one. So since k is greater than equal to 8, therefore the value of k is going to be equal to 8. So this will be the smallest possible value that k can take. Now the next part of the question, let me show you the next part. It is actually requiring us to find the range of fg. So I'm going to start it like this. We know So what do we know? We know that f of x is 3x negative 2 whole squared positive k, and since k is equal to 8, my f of x is going to be 3x negative 2 raised to the power of 2 positive 8. Now g of x is equal to 5x negative 1, so therefore f of g of x is equal to f of 5x negative 1, which is equal to, in place of x we substitute 5x negative 1, so it's going to be 3 times of 5x negative 1 negative 2 raised to the power of 2 positive 8, and this is my f of g of x, which is also written as fg of x. So if we were to expand this, this will give us 3 times of 5x is 15x, negative 3 negative 2 whole squared positive 8, which is going to be 15x negative 5 whole squared positive 8. Okay, now the question is, what is the minimum value for fgx, or I would say f of g of x? The minimum, so that is actually the required range, right? The minimum possible value for fg of x occurs only when 15x negative 5 whole squared is equal to 0. So why do I say that? Since 15x negative 5 whole squared is quadratic, and the minimum value, minimum possible value will be 0, and that is why I am writing it as 15x negative 5 whole squared is equal to 0, right? So this in turn would mean the smallest possible value that f of g of x can take will be equal to 8. So therefore the range, this is what is required, range of fgx, or you can write it as f of g of x, is all values starting from 8 onwards. So this is the solution. So let's move on. So the last part, we are asked to find g inverse of x and h of x, given that we have g h of x to be equal to 35x positive 19, and g of x is equal to 5x negative 1. Okay, now what I wish to do is, I would like to calculate, we will first find g inverse of x. So how are we going to do this g inverse of x? Foremost, what I would do is, I will rewrite this as, let us rewrite, say I'm going to take this as sum 4 as y is equal to 5x negative 1. Then you replace y by x and x by y. So x is equal to 5y negative 1. Then you rewrite the above for y. So that's going to be x positive 1 is equal to 5y. So therefore y is equal to x positive 1 over 5. So this means my g inverse of x is x positive 1 over 5. Now also given, what is given? G h of x. Okay, g h of x is equal to 35x positive 19. So if I were to move this g to the other side, I would have g inverse as g inverse of 35x positive 19. This is what I would get. Now g inverse of x is equal to this quantity, right? So this would mean, take this and substitute over there. So it's going to be 35x positive 19 in place of x positive 1 divided by 5, which is going to be 35x positive 20 divided by 5. So h of x, so therefore h of x is 35x positive 20 divided by 5. Okay, now you can simplify this by taking say 5 out. I will get 7x positive 4 divided by 5. 5 gets cancelled. So therefore h of x is equal to 7x positive 4. So we have got h of x, we have found g inverse of x, and we have also completed the above parts of the question. So that means the completion is achieved. So we'll move on to the next one.